Hello mga ka-cute angels! Welcome back for another Mathinate episode. This is Teacher Mika
and this is Teacher Jammy.
Today, we will learn about sets, subset universal sets, null set, cardinality of sets, union and intersection of sets, and the difference of two sets.
In Lesson 1, you have learned how to illustrate sets. Now you will learn about subsets, universal sets, null sets, and cardinality of sets.
Let's have an activity before we start our second lesson. Given set A is the set of whole numbers less than 11. Find the following. Number 1, the set of odd numbers. Number 2, the set of all factors of 10. Number 3, the set of multiples of 4. And number 4, the set of negative integers. You have 1 minute to do this activity. Let's check your answers. Recall that our given is set of whole numbers less than 11. So for the number 1, the set of odd numbers. The set of odd numbers are 1, 3, 5, 7, and 9. Number 2, the set of all factors of 10. The answers are 1, 2, 5, and 10. Number 3, the set of multiples of 4. Therefore, the elements of the set of multiples of 4 are 4 and 8. Number 4, the set of negative integers. Our answer will be an empty set because whole numbers doesn't have negative integers.
Let's have the universal set denoted by capital letter U. The universal set U is the set that contains all objects under consideration. Examples. Number 1, set U contains the set of whole numbers. So, the universal set would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Number 2, set U contains the set of all letters of the English alphabet. The universal set would be A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. And lastly, set U contains the set of days of the week. So the universal set would be Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday.
Let's talk about subsets. Given any two sets A and B, if every element in A is also an element in B, then A is a subset of B. Take a look at this symbol. This symbol is read as A is a subset of B. Note that every set is a subset of itself and empty set is also a subset of every set. Let's have this illustrative example. Say that I'm craving to have a frap this afternoon. And I have 3 options to choose from: vanilla, strawberry, and chocolate. If I am to choose one frap only, it can be vanilla or strawberry or chocolate. But what if I feel like having 2 fraps at the same time? So the possibilities are vanilla and strawberry and chocolate, or vanilla and chocolate. And what if I feel like to have all the fraps? That means I will have the vanilla, strawberry, and chocolate all together. There is another case that what if I'm feeling sick and my doctor don't want me to have the frap? That means we will have an empty set. What we need to remember is that all the sets below are subset or part of the given set. Let's further understand. Number 1, R is a set of numbers 1 and 2. We will now list all the subsets of set R. Take a look on our table. Let's have first the zero element or the empty set. Remember that empty set is also a subset of every set. Next we have subset with one element. These are 1 or 2. And lastly, we also have the set itself, 1 and 2, because set is a subset of itself. Therefore, we have 4 subsets in the set R. Example number 2. O is a set of colors red, blue, and yellow. We will now list all the subsets of set O. Let's have a look. Let's have first the zero element or the empty set. Again, empty set is also a subset of every set. Next we have subset with one element. These are red, or blue, or yellow. Another is the subset with two elements. These are red and blue, red and yellow, blue and yellow. And lastly, we have 3 elements, red, blue, yellow. Therefore, we have 8 subsets in the set O. For example number 3, set S is a set of multiples of 3 less than 15. Let's now list all the subsets. First, the zero element or the empty set. Next, only one element. These are 3, or 6, or 9, or 12. Another subsets are the combination of the two elements. We have 3 and 6, 3 and 9, 3 and 12, 6 and 9, 6 and 12, 9 and 12. Also, we can have the combination for the 3 elements. We have 3, 6, 9, 3, 6, 12, 3, 9, 12, 6, 9, 12. And lastly, the combination for the 4 elements. 3, 6, 9, 12. Therefore, there are 16 subsets for the set S. Now, try to answer example number 4. I will give you 2 minutes to answer. Let's check your answers. We have the zero element or the empty set. Next, there are 5 subsets for the one element, 10 subsets for the combination of 2 elements, 10 subsets also for the combination of 3 elements, 5 subsets for the combination of 4 elements, and 1 subset for the combination of 5 elements. All in all, we have 32 subsets for set G.
Now, what if the question is just asking you only the number of subsets a given set has? What are you going to do? Will you still list its subsets, or do you have a technique in finding so? Okay, so let's find that out. Let's go back to example number 1. The given set has 2 elements and yields 4 subsets. Example 2 has 3 elements and yields 8 subsets. And example 3 has 4 elements and yields 16 subsets. From those examples, we can establish a pattern that as the number of elements in a set increases, the number of its subsets doubles. With that, we conclude that the number of subsets in a given set can be computed through the formula 2 raised to n. Going back again with our previous examples, we can now compute the number of their subsets by just using the formula 2 raised to n, where n is the number of elements given in a set. For number 1, set R has 2 elements. Using the formula, which is 2 raised to n, that would be 2 raised to 2, which is equal to 4. Number 2, set O has 3 elements. Using the formula, that would be 2 raised to 3, which is equal to 8. Number 3, set S has 4 elements. Using the formula, that would be 2 raised to 4, which is equal to 16. And number 4, set E has 4 elements also, so that would be 2 raised to 4 equals 16. And lastly, set G has 5 elements, so that would be 2 raised to 5, which is equal to 32.
Now, let's talk about the null set. A set with no element is an empty set or null set. The symbol for empty set is an empty curly braces or the ancient Greek symbol phi. Let's analyze. Number 1. Set T is the set of counting numbers between 1 and 2. This is an example of an empty or null set because there are no counting numbers between 1 and 2. Therefore, we write it as set T is equal to empty set or null set. Example number 2, set I is the set of months with 35 days. Set I is also a null set because we do not have months with 35 days. We only have 31 or 30 days in a month, and sometimes 28 days in a month. So, set I is a null set. Number 3, set M is the set of cars with 60 doors. Imagine what a car looks like if it has 60 doors. As of today, we don't have cars like that. Means, set M is a null set. Example number 4, set B is the set of flying castles. This example is impossible. Maybe in fairy tales but not on the real-life situations. So, set B is a null set. And lastly, number 5, set E is the set of squares with 6 sides. As we all know, square has only 4 sides. The shape with 6 sides is called hexagon. Therefore, set E is a null set.
Now let's have the cardinality of set. The cardinal number of set A, denoted by n of A, is the number of elements in set A. For example, in A equals 1, 3, 5, 7, the cardinal number of set A is 4 because set A contains 4 elements. Let's have some more examples in identifying the cardinality of a set. Number 1, set D is the set of vowels in English alphabet. So if we are going to list the elements of that set, we have D equals A, E, I, O, U. Therefore, the cardinality of set D is 5. Number 2, set R is the set of letters in the word difficulty. If we are going to write the elements of that set, we have R equals D-I-F-C-U-L-T-Y. Remember that we just list the same element once. Therefore, the cardinality of set R is 8. And lastly, set M is the set of odd numbers between 1 and 3. If we are going to list the elements of that set, we have a null set or an empty set because there is no odd number between 1 and 3. Therefore, the cardinality of set M is 0.
It's activity time! Find the cardinality of the following sets. Number 1, set A is the set of days in a week. Number 2, set B is the set of letters in the word recognition. Number 3, set C is the set of even numbers less than 2. Number 3, set D is the set of odd numbers between 3 and 9. And number 5, set E is the set of factors of 12. I will give you 1 minute for these stats. Let's check your answers. Number 1, the cardinality of set A is 7. Number 2, the cardinality of set B is equal to 8. Number 3, the cardinality of set C is equal to 1. Number 4, the cardinality of set D is equal to 2. And number 5, the cardinality of set E is equal to 6. Did you get all the answers right?
And we are down to our last lesson on sets, which is the union and intersection of sets, and the difference of two sets, also known as the operations on sets.
Let's have an activity before we start our last lesson. Identify if each statement is true or false. Write your answer in the space provided. Given set U is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Number 1, the universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Number 2, 2, 4, 6, 8, 10 is a subset of set U. Number 3, 0, 10 is a subset of set U. Number 4, empty set is a subset of set U. And number 5, the cardinality number of set U is 10. I will give you 30 seconds to finish this activity. Time's up. Let's check your answers. Number 1, the answer is true because it contains all the elements in set U. Number 2, the answer is true because elements 2, 4, 6, 8, 10 are part of the set U. Number 3, the answer is false because there is no 0 to combine with 10 in the elements of set U. Number 4, the answer is correct, true, because every empty set is always a subset of a set. And number 5, the answer is true, because set U contains exactly 10 elements.
Now we will discuss 3 operations of sets. The first one is the union of set, denoted by this symbol. It is the set containing all elements that are in set A or in set B. Next is the intersection of set, denoted by this symbol. This is the set that consists of all elements that are both in A and B. And we have also the difference of two sets, denoted by minus sign symbol. It is a set of elements in A that are not in B, or the other way around.
Let's further examine. Union of sets. Say that A union B. That means set of elements that are members of A, or members of B, or members of both A and B. Let's have some examples. Number 1. If set A is 1, 2, 3 and set B is 1, 2, 4, 5, 6, then A union B is 1, 2, 3, 4, 5, 6. You'll just combine all the elements of A and all the elements of B. Number 2. If set A is A, B, C, D, E and set B is A, E, I, O, U, then A union B is A, B, C, D, E, I, O, U. And lastly, number 3, if set A is Monday, Tuesday, Wednesday, Thursday, Friday, and set B is Saturday and Sunday, then A union B is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday.
Next, we have the intersection of sets. Say we have the intersection of set A and set B. Then this is the set of all elements common to both sets A and B. For example, number 1, if A is equal to 1, 2, 3 and B is equal to 1, 2, 4, 5, 6, then the intersection of set A and set B is 1 and 2. Number 2, if A is A, B, C, D, E and B is A, E, I, O, U, then the intersection of A and B is A and E. And number 3, if A is Monday, Tuesday, Wednesday, Thursday, Friday, and B is Saturday and Sunday, then the intersection of A and B is a null set or an empty set.
Let's talk about difference of two sets. Let's have A minus B. It means to say that the set of elements in A that are not in B. Here are the examples. Number 1, if set A is 1, 2, 3 and set B is 1, 2, 4, 5, 6, then A minus B is equal to 3 because the element 3 that is in set A is not an element of set B, while B minus A is equal to 4, 5, 6 because elements 4, 5, 6 of set B are not the elements of set A. Number 2, if set A is equal to A, B, C, D, E and set B is equal to A, E, I, O, U, then A minus B is equal to B, C, D, while B minus A is equal to I, O, U. And lastly, number 3, if set A is Monday, Tuesday, Wednesday, Thursday, Friday, and set B is Saturday, Sunday, then A minus B is still Monday, Tuesday, Wednesday, Thursday, Friday, while B minus A is Saturday and Sunday.
We also have the complement of a set. The complement of set A is denoted by this, read as A prime or A complement. The complement of a set is the set of all elements that are not in the given set. Let's have some examples. If universal set Q is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and set A is 1, 3, 5, 7, 9, set B is 2, 4, 6, 8, and set C is 1, 2, 3, 4, 5, 6, find number 1, the complement of A or A prime. So since U is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and A is 1, 3, 5, 7, 9, just remove all elements of set A that are in the universal set U. Therefore, we will eliminate 1, 3, 5, 7, and 9. And that leaves us the complement of set A to be 2, 4, 8, and 10.
Number 2, the complement of B or B prime. Since U is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and B is 2, 4, 6, 8, just remove all the elements of set B that are in the universal set U. So we will remove 2, 4, 6, 8. Therefore, the B complement are 1, 3, 5, 7, 9, and 10.
And lastly, find the complement of set C. So since U is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and C is 1, 2, 3, 4, 5, 6, again, you will just remove all elements of set C that are in the universal set Q. So we will eliminate 1, 2, 3, 4, 5, and 6. Therefore, the complement of set C or the C complement is 7, 8, 9, 10.
That ends our lesson today. We hope you learned something. See you on our next episode, Acute Angels. Keep safe.